we have to find a unit vector along PQ. Like, see, if I take this vector PQ vector as A vector, then we have to find A cap. A cap is equal to A vector by its magnitude. Okay, first, let us take this point is x1, y1, z1. This is x2, y2, z2. Then PQ vector. PQ vector is given by x2 minus x1 into I cap plus y2 minus y1 into j cap. When they have given two different points, with help of this formula, we can find vector. PQ vector I'm taking as vector A. So this is x2 minus x1, 4 minus 1, that is 3 I cap plus 3 j cap plus 3 k cap. This is the required vector PQ, but unit vector means the magnitude must be 1 unit distance. Okay, so let us take this is R, PR. We need to find vector PR. Nothing but simply, therefore the unit vector of PQ is equal to A vector is, shall I write the property A cap is equal to vector A by magnitude of A vector. Okay, now I'm going to find magnitude of A. So that is magnitude of A is 3 square plus 3 square plus 3 square. Okay, so this is equal to root 27 means 3 root 3. Okay, so here this is magnitude. Now, therefore, what about the unit vector? A cap is equal to A vector by magnitude of A, that is 3I plus 3J plus 3K, all divided by magnitude of A. Magnitude of A is 3 root 3. Now write it separately. 3 by 3 root 3 I plus 3 by 3 root 3 J plus 3 by 3 root 3 K. So finally, the answer is unit vector is 1 by root 3 into I cap plus 1 by root 3 into J cap plus 1 by root 3 into K cap. That's it. This is a required a unit vector along the vector PQ. Along the vector PQ. Okay, students? Right. First, you have to find the vector PQ with help of that. Otherwise, you have to find the position vector, OP vector. OP vector, the second method is OP vector. You can find OQ vector. After that, PQ is equal to, PQ vector is equal to first to OQ minus OP. This is also very easy method 2. Coming to the next question. See, for the vector A and B, find the unit vector in the direction of A plus B. This question you can do, students. Like I'm taking vector C as A plus B vector. C as A plus B. So what is A plus B when adding these two? I minus J plus J, 0J, and plus 2K minus K, that is K. So this is I plus K. So this is A plus B. Now you can find C cap is equal to vector C by magnitude of C vector. That you can do that. And coming to the question number 10. Before going to question number 10, so if A be the given vector, like A be the given vector, which implies unit vector, A cap is equal to vector A by magnitude of A. Am I right? From this, can I write the vector A is a magnitude of A, cross multiply this. You can cross multiply this. Magnitude of vector A into A cap. Shall I write? Whether we can write or not? Yes, we can write. Okay. We can write very easily. So A cap is equal to vector A by magnitude of A. Magnitude of A you can cross multiply. Now coming to this question, find the vector in the direction of this given vector, this vector, which has magnitude is 8 units, which has magnitude of 8 units. Nothing but what shall we do, students? Already they have given a vector. Let us take here, this is the vector A. This is a vector A. See, along this vector, they are asking, okay, so in the question what they are asking, with magnitude is 8 units, you have to find the vector in 8 units. I want to take from here to here, from initial point to here, 8 units. I'm taking 8 units. This overall total, like this vector equation they have given in the question, but I required from here to here only, from 8 units in this vector. For that, what shall we do? First, we have to find a unit vector. Unit vector. We have to find the unit vector. That unit vector we can multiply with 8. Indirectly, they are asking here, we need to find 8 is a magnitude. A unit vector is A cap. 8 A cap value they are asking. Okay. In the question, I want to take your solution. Let us consider given vector is A vector. A is equal to 5i minus j plus 2k. Okay, 2k. So very easy, student. Vector A. In this direction, we required a vector of 8 units. Magnitude is 8 units, nothing but 8 A cap. Since we know that to find A cap value, we know that vector A by magnitude of A. With help of the given vector, first you have to find magnitude of A. So root over 5 square minus 1 square plus 2 square, that is clearly equal to root over 25 plus 1 plus 4, that is root 30. Fine. Now, the unit vector you have to find A cap is equal to vector A by magnitude of A. Simple. Vector A already 5i minus j plus 2k by square root of 30. But this is okay, A cap, unit vector we found. So in unit vector, in how many units we require to find? 8. Therefore, you have to write here a vector, the required vector along in the direction of 5i minus j plus 2k of so which has magnitude 8 units is 8 A cap. Simple, student, multiply this with 8. That is required vector. That is equal to what? 8 times of 5i minus j plus 2k all divided by square root of 30. This is the answer. You may multiply here. 8 5s are 40. 40 by root 30 I and 8 by root 30 j plus 2 by 16 by root 30 k. You may write any one of the way. This is the required answer. See, student, what I have done? Already magnitude is given. Just find unit vector. That's all. Unit vector you can find, multiply with 8 units, because when you find a unit vector, you will get a unit length. And when you change to unit vector, so whatever the coefficient you are getting I, j, k coefficient, that must be L, M, N, direction cosines. See here in this question, I found 1 by root 3, 1 by root 3. These are the L, M, N. L value, M value, N value. L value, M value, N value. After changing into unit vector, after finding unit vector, the coefficient of I, j, k are the direction cosines. See here this question. For example, we have done one question, question number 6. Yeah. In question number 6, what we have to find here? Question number 6, find the, not sum. Question number 7, sorry, 7. Find the unit vector. Means here I plus j plus 2k is given. I coefficient 1, j coefficient 1, k coefficient is 2. This 1, 2, 1, 1, 2. This 1, 1, 2 are called direction ratios. Direction ratios. But after finding unit vector, whatever the coefficient 1 by root 6, 1 by root 6 and 2 by root 6, these are the direction cosines. Direction cosines. You can take this is L, this is M, this is N. So you may get doubts, sir, how can we say that direction cosines? Direction cosine, one property is there, that is always L square plus M square plus N square is equal to 1 or not. In every question, whether the coefficient of I, j, k are direction ratios or direction cosines, to check that, you can find L square plus M square plus N square. If it is equal to 1, if it is the coefficient of I, j, k, sum of the squares of I, j, k, it is 1, direction cosines. It is not 1, direction ratios. Direction ratios. Okay. Now see here, directly the given matrix 1, 1, 2. 1 square plus 1 square plus 2 square, it will become 6. Is 6 is equal to 1? No. It is possible for every a unit vector. In a unit vector, then always L square plus M square plus N square always equal to 1. Any doubts, students, in this question? I hope that no doubts. We are coming to the question number. Yeah, question number 11. Question number 11, very easy. Collinear. I told you very clearly in the morning class, when you want to say any two vectors are collinear, this is vector A and this is vector B. For example, this is having 5 units length. This is having 10 units length, vector B. So vector B magnitude is 10, vector A's magnitude is 5. Shall I write B vector is equal to 2 times of A vector? Magnitude of A is 5 and magnitude of B is 10. Shall I write B vector is equal to 2 times of A vector? Yes. This is in the form of B vector is equal to lambda times of A vector. Now, whenever here it is satisfying the property like any vector, we can write lambda times of another vector here. Lambda belongs to R. Morning itself I explained this. Okay, then these two are collinear. Like how can we check that? One vector must be lambda times of another vector. See here. Given vector, let us take this is A, vector A, 2 minus 3, 4. Let us take vector A is equal to 2i minus 3 plus 4. And let us take B vector is equal to, simple students, the given vector A, you can multiply with minus 2. When you multiply with minus 2, what? You will get the vector B. Let us take B is minus 4i plus 6j minus 8k vector. Now, these are the two vectors I am considering as A and B. I told you very clearly when we want to say A comma B are collinear. So one vector is equal to lambda times of another vector. Shall I take a B vector? Shall I write B vector is equal to a minus 2? I am taking common, then 2I minus 3J plus 4K. Sorry. Okay, plus 5. I am taking minus 2 common. Then what about this vector? This vector is clearly what? This vector is vector A. So minus 2 times of A vector. Now we express this is in the form of B is equal to lambda times of A. Okay, here B is vector is equal to lambda times of vector A. Nothing but here where what is the lambda value? The lambda is equal to minus 2. So therefore what we can conclude here? So it is clearly belongs to real number. Therefore A comma B are collinear. Collinear, that's it. One vector we can represent lambda times of other vectors. That's it. Then next. Any doubts, friends, here? Next, coming to the next question. Find the direction cosines. Direction cosines of the vector joining the points directed from where to where here? A to B. Okay. Very, very simple. I think for other section I explained already direction cosines. Direction cosines. Very simple, students, when they're given two different points. Like, okay, let us take here, this is point A, I'm taking x1, y1, z1. The point B I'm taking as x2, comma y2, comma z2. Here very simple, first direction ratios. Before finding direction cosines, you should find direction ratios. Direction ratios. This about direction cosines and direction ratios we will discuss very briefly next chapter, that is three-dimensional geometry, right? Direction ratios means when they have given two different points, the direction ratios are given by x2 minus x1, comma y2 minus y1, comma z2 minus z1. Got it? These are the direction ratios. And when I find the distance AB, when I find the distance between 2 points, AB, what is the distance formula? x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. This is distance formula. So direction ratios directly is given by x2 minus x1, y2 minus y1, z1. But direction ratios, okay, direction ratios is directly direction cosines. What about direction cosines? DCs, simply we can write direction cosines as DCs, and direction ratios are DRs. Okay, in textbook also sometimes they represent like this. Direction ratios are DRs. Okay, direction cosines are DCs simply. In OBT, simply they mention DCs or DRs. DR nothing but direction ratios, DC is nothing but direction cosines. After finding the direction ratios from A to B, the direction cosines are given by same x2 minus x1 by AB, comma y2 minus y1 by AB, comma z2 minus z1 by AB. That's all. Got it, students?
Yes.
Yeah, now, okay, fine. Here, instead of P, they have given, what are the points they have given? 1, 2, minus 3. This point is 1, 2, minus 3. And this point they have given here minus 1, minus 2, minus 1, minus 2, and 1. Okay, students, 2 points they have given. Is it difficult? First, you have to find direction ratios. Direction ratios are, what are the direction ratios here? Minus 1, minus 1. Because direction is very important. It is directed from A to B. Don't take X. So this is X1, Y1, Z1. This is X2, Y2, Z2. You should take X2 minus X1 only. Y2 minus Y1, not X1 minus X2. Okay. So minus 1, minus 1, minus 1, minus 1, comma, minus 2, minus 2, comma, 1, minus of minus 3. So this is equal to minus 2, minus 4, 4. Okay, these are the direction ratios. But to find the direction cosine, first we have to find AB distance. Root over x2 minus x1. Same, minus 1, minus 1, minus 2 the whole square. This squares, that's it. Here minus 4 square plus minus 2 square minus 4 square plus 4 square. That's it. This is length. 4 plus 16 plus 16. 36, that is 6. Got it? Therefore, after this, direction cosines, DCs, direction cosines are same. Minus 2 by 6, minus 4 by 6, 4 by 6. Direction ratios by the distance, like magnitude, it's magnitude. That is in the sense direction cosine means find unit vector coefficient of ijk. Even if you find the unit vector here, surely you are going to get this. Now here it can be there minus 1 by 3, minus 2 by 3, and 2 by 3. Got it? Simple. What I have done, x2 minus x1, y2 minus y1, z2 minus z1, direction ratios. Direction cosines means after finding ratios, find the distance between 2 points, then dividing with, divide to the direction ratios. We'll get direction cosines. When you're squaring and adding, let us take this is L, this is M, this is N. L square plus M square plus N square. Always equal to 1. You can check it once. Direction cosines can be denoted by L, M, N. When you're squaring and adding, surely you are going to get 1. 1 square plus 2 square plus 2 square. 1 plus 4, 9. By 3 square, 9. 9 by 9, 1. Got it, students? So this is the answer from direction ratios from A to B. Any doubts, students? Now coming to the next question. Show that the vectors I plus j plus k is equally inclined to the axis OX, OY, OZ. So what is the question here they are asking? Alpha, OX means alpha, OY means beta, OZ means gamma. Now we have to show that alpha is equal to beta is equal to gamma. That's it. Okay, students, let's see now. Now I'm going to take the 3 dimensions. X-axis, Y-axis, and Z-axis. Okay. Right. There is a point P. We can join them. Yesterday I explained in the classroom, like P is any point in the space, not on XY plane, not on YZ plane. In this before class also clearly explained. This is X-axis, this is Y-axis, this is Z-axis. And X-axis can make an angle alpha. Y-axis can make an angle beta. Z-axis make an angle gamma. Alpha, beta, gamma. Got it? Alpha, beta, gamma. Then angle means first you have to find L value, M value, N value. That's it. L nothing but we know that cos alpha. M nothing but direction cosine cos beta. The cosines values of given directed angle here alpha, beta, gamma are called directed angle. The cosines values of directed angle is direction cosine. C section. Is that clear? Cos alpha, cos beta, cos gamma are called direction cosines. Cosine means cos. So now we have to find cos alpha value, cos beta value, cos gamma value with the help of the given vector. Already given vector, OP vector they have given. Like this OP I am taking as, what is the vector they have given? I plus j plus k. I plus j plus k. When I coefficient, j coefficient, k coefficient are 1, 1, 1, all are equal. So that surely we'll get the equal angle. But we need to find those angles. Those angles, right? This OP vector, I'm taking as, okay, OP vector, that is, I'm taking as OP vector as R vector. R vector is equal to I plus j plus k. Now, is it a unit vector? No. Whenever they ask you to find the like angle between the vector with the coordinate axis, very simple. You have to do in two ways. One is you have to find the unit vector r cap. R cap is equal to vector r by its magnitude of r. This is one way. Other way is, let us take origin is 0, 0, 0. The point P is 1, 1, 1, like that. Okay. That is method 2. Method 2 is not required because vector equation already given. Whenever you want to find the direction cosine, you must be find a unit vector. R cap is equal to vector r, I plus j plus k by magnitude means root over 1 square plus 1 square plus 1 square. Got it? So R cap is equal to I by root 3 plus j by root 3 plus k by root 3. Now this you have to comparing with Lx plus my, sorry. Lx plus my means that is belongs to again 3 dimensional. Lx plus mj plus nk. So when I compare after finding the unit vector with the Li, because I told you very clearly every unit vector, the coefficient of I, j, k are represent direction cosines. So now L is equal to, L nothing but what, student? Cos alpha is equal to 1 by root 3. M is nothing but what? Cos beta. Cos beta is 1 by root 3. N nothing but what, student? Cos gamma. Cos gamma is equal to 1 by root 3. Which implies, what is alpha, student? Alpha is equal to, shall I write cos inverse of 1 by root 3. Beta is equal to, shall I write cos inverse of 1 by root 3. Gamma is equal to, shall I write cos inverse of 1 by root 3. Yes, we can easily write. So see here, what about the angle? All angles are same, cos inverse 1 by root 3, 1 by root 3, 1 by root 3. So therefore, alpha is equal to, beta is equal to gamma. Alpha is equal to, clearly beta is equal to gamma. What shall we conclude here? Therefore, alpha is equal to beta is equal to gamma, that is equal to cos inverse of 1 by root 3. So finally, you have to write hence the given vector which equally inclined to OX, OY, OJ. That's it. Alpha, beta, gamma with the angle with x-axis, y-axis, z-axis respectively. Then after you can do this process. First, what I have done, simply I found that unit vector. I found the unit vector After finding the unit vector, I comparing with Lx, Li, Mj, Nk. L value is cos alpha, M value cos beta, N value cos gamma. That's all. Any doubts, students? After that, alpha is equal to cos, I'm taking right side. Simple. Having any doubts, you can ask to me. Right, next. Question number 15. How many questions totally? First, let us do this 18, 19. See, students, in a triangle.
Can you show the slide 1 minute, sir?
Yeah.
A little down.
Thank you, sir.
Sir, little up, sir. Yes, sir.
Okay.
Thank you, sir.
This question. Right. So finally here vector in that nothing but displacement from one point to another point. Displacement from one point to other point. For example, the person like you can take any person like Raghav. For example, Raghav is a person. He started at the point A, he reached at the point B. Again, he changed the direction. He changed his direction. He went. He is moving towards the point C. Finally, he reached to C. Finally, what is his displacement? From A to C only. Okay, A to C. The displacement of the person Raghav is A to C. So nothing but what shall we, if I take this vector is A, this vector is B, then this vector is C, then C vector should be equal to A vector plus B vector. Okay, A vector plus B vector. So what is C vector here? C vector means initial point is A vector, AC vector. A vector means AB vector plus BC vector. Don't worry, students. I can explain you again. We easy only. A plus B triangular inequality. I think you know very well this. In class 11th already you studied this vector concept, right, in physics. So AC vector is equal to AB. But according to this, which is correct, students? And see, for every vector, vector AB always can be written as minus BA vector. If I change the point, position of the points like A and B minus BA vector. Okay, when I take this AC vector is right side, because AB plus BC, AB plus BC, AB plus BC is there. So AB vector plus BC vector minus AC vector is equal to 0. Okay, then which is correct option, students? AB, BC. Which one of the following option is correct?
Both B and C.
Yes. Actually, here it is plus. You can change the option B, that is plus. AB plus BC plus AC is equal to 0. Option C is right. You can change the option in the question. So option C
Which
is
is not true, sir.
Oh, which is not true, sir.
why which is not true?
So in the question it's given like that, sir.
Oh, which is not true. Means, yeah, this is only not true. Nothing but this is only correct, you know. Oh,
Sir, first option is wrong, sir.
which is not true means I'll tell you. AB plus BC plus AC plus, okay. First option is offline class. Yes, twin. First option is wrong according to this. Which is wrong? Tell me first. Option A or option C? AC minus B. According to the direction, you can just check it once. Option A is C here. AC direction is there. This is true only. This is starting point, ending point. A vector to A vector, always 0. Correct only. But when I take this plus, plus when I take plus here, AB plus BC, like AB plus BC, this AC vector also here we got it. AC vector also AB plus BC. Just mobile and try. Mobile and try. This is not equal to, but this one not true. This is only not true. Minus AC we got. This is true. Then AB vector minus CB vector. Fourth option is true. So what is the wrong option, students? As per the property, according to the vector properties, starting point is A, ending point is A. So A to A, this is always 0 because initial point, terminal point coincide. So that 0. And coming to 19th, which one of the question is wrong? Students? Are two collinear vector. Which of the following is incorrect? This is true. This is true because lambda value is plus or minus 1. Both vector A and B are same direction. Same direction. Is it compulsory? Yes. Option D is correct. Because this is wrong statement. The collinear vector should not be in the same direction, maybe opposite direction. It's not necessary that different magnitudes. It may be same magnitude. Okay, students, remaining 2 questions will do. And tomorrow, surely I'm going to ask questions on this concept. Be ready. Okay.